Okay, we are going to work on pages 22, 23, and 24 and 25 today in this video. So we are still working on addition and subtraction methods for integers. And so we're going to look at this example here. So Jackie is sitting on a rock 5 feet above the surface of a pond. You can see there she is 5 feet. She's this little dot. She drops a stone that falls 8 feet to the bottom of the pond. What's the stone's final position relative to the surface of the pond? So 0 is going to be, we can mark that as the surface of the pond. And she's sitting up here. We'll draw a picture of her sitting up here, and then here's the stone. And so where does the stone end? So this is how you could show your work using a number line. 5 minus 8, starting at 5, subtracting 8 is equal to 5 plus negative 8. Again, first number stays the same. Change the operation. Take the opposite of this number, which is 8. So that's negative 8. So our solution is negative 3 feet, or 3 feet below the surface of the pond. All right. I'm going to make this more pond surfacey. There we go. That looks more like a surface of a pond, huh? And there's a little fish right there. The rock scared the fish. Okay. So how else could you solve this problem? We want to pair share that. So let's pause for a second and pair share how else we could solve this problem. Okay, so let's look at number 17. Kelly's dad compares her running times in a marathon to her times for last year's race. Her records whether she has increased or decreased her time for the first 3 stages of the race. He records whether she has increased or decreased for the first 3 stages of the race. What is the total increase or decrease in Kelly's time? Did she improve in her time? So this time, the first stage, she was 4 minutes more. The second stage, she was 7 minutes less. And in the third stage, she was 3 minutes below that. So the question is, and I already answered it, does a negative number represent an increase or a decrease in Kelly's time compared to last year? So a negative number shows a decrease in time. So here's a pair share. Well, let's do the solution first. And I am going to do this with a number line. So give me a second to draw the number line. Poof, there's the number line. Okay, so she's going to start at +4. So she's going to start right there, because that was in her first stage of the race. She was 4 minutes above, and then she was 7 minutes less. So 1, 2, 3, 4, 5, 6, 7. And then in the third stage, she was even 3 minutes less. So 1, 2, 3. And so by this number line, it looks like she would have ended at -6. So 6 minutes less than the previous race. So if we just did an expression here, that would be 4 plus -7 plus -3. And we could look at -7 and -3 and say that that is -10 together, and 4 plus -10 equals -6. Okay. Number 18. A helicopter is 19 meters above the top of a canyon wall. It goes down 27 meters, passing into the canyon, and then goes up 5 meters. What is the new position of the helicopter relative to the top of the canyon wall? Okay, so again, we're going to do a number line. So the question is, do you use a positive or negative number to represent the helicopter going down 27 meters? So you can answer that together while I draw the number line. And so the helicopter is 19 meters above the canyon. And if we say that the canyon wall is at 0, that's the top of the canyon. And so it says that the helicopter, which I can draw a helicopter, that's not hard, right? So here's our helicopter, and it's here at 19, and then it goes down 27 meters. So the question is, do we use a positive or a negative number to represent that helicopter going down 27 meters? And I will say, I'm hoping you guys said negative, so it's going to go down or minus 27. And so in my number line, I'm just using this to draw representation. I'm not drawing all of the dashes this time. And but if I was to write this part of the expression, I would write it as 19 minus 27, and that is equal to -6. So right here is -6. Wait a second. I'm going to check that. So if we pull up the calculator, let's see, we're going to say 19 minus 27, and it's actually -8. So I thought something was fishy there. So that was my bad. And now I'm just making weird marks everywhere. So that's going to be -8. So now it's flown down. The helicopter has flown down 27 meters and then goes up 5 meters. And so the next step of the helicopter is to go up. So that's +5. And I need to change this to -8. Okay, so now we have a new expression, -8 plus 5. So we don't get all the way back to 0. That is -3, and that I don't have to do on a calculator. You guys can if you feel like you need to. So that's our solution, is -3. So what does a negative answer mean in this situation? So what does this negative mean? Talk about that for just a second. A negative solution means that the helicopter is still below the top of the canyon, or below the canyon wall, at the end of this part of the flight of the helicopter. Okay, number 19. At 7 o'clock a.m., the temperature in Wilton was -6 degrees Fahrenheit. We can be reading there. By 8 a.m., the temperature was 2 degrees Fahrenheit. What is the difference in the temperature between 8 a.m. and 7 a.m.? Is it -8 degrees, -4 degrees, +4 degrees, or 8 degrees? Siri chose B as the correct answer. How did she get that answer? So she chose B as the correct answer here. How did she get that answer? So this is a different type of question than you finding the answer. It's asking you to think about what Siri chose. So I'm going to say that she probably said -6 degrees Fahrenheit plus 2 degrees Fahrenheit equals -4. I'm betting that's what she did. But does Siri's answer make sense? Why or why not? So go ahead and talk about that. So I'm hoping that you said that it doesn't make sense, because the real correct answer is D, because if she started at -6 and here's 0, she would have to go 6 this way, and then to get to 2, another 2 this way. So it's actually 6 plus 2, which is 8. And so this question here, to find the difference between two temperatures, and we've been talking about this quite a bit over the last couple of days, the difference is subtraction. So the way that we would set this up to get the correct answer, so this part goes down here, but the way we would set this up is we would say -6 the difference minus 2. Nope. Sorry. We would want to set that up with the 2 minus a -6. And then that would be 2 plus 6, which equals 8, which is what we have here. The 2 plus the 6 gives us the 8. Okay. So this is, as you can see right here, independent practice. So I want you guys to take a little time to work on this on your own, and then I will do some think alouds as we work through these problems. Okay, a submarine is 50 meters below sea level. It goes up 15 meters, so 50 meters below, up 15 meters, then goes down 40 meters. What is the submarine's new position relative to sea level? So this one you should use a calculator for and be able to use a calculator. So I'm going to say 50 meters below sea level. We start at -50. And then we go up 15, and then down another 40. Okay, so if we use a calculator here, we would say 50 negative plus 15 minus 40, and that equals -75, which is D. So that would be the answer to number 1. Number 2, the table shows the temperatures and wind chill temperatures in 4 towns. Which town had the greatest difference between the actual temperature and the wind chill temperature? Well, here we're at -3 to -13, so that is 10 between those two. 0 and -10, that's a difference of 15. 10 and -10 ends up being a difference of 20, because you've got, if we're looking at here, -10 and 10, you've got 20 spaces in between those, so that's a difference of 20. And West Falls, if you're at -17 and 2, you end up with a difference of 19. So I would say that that's a difference of 20 there. That's going to be your greatest difference. Look at the equations below. Choose true or false for each equation. I'm going to let you guys work on those ones. The one, and you can use a calculator for these. So the one that I'm looking at here that I think would be interesting to work through is this one, and I'm going to change this part to an addition problem and this part to an addition problem, and let's see what happens. So we go 24 plus 6 minus 6, okay, equals 24. So is this true or false? Well, 26, if we have plus 6 minus 6, we call those, remember, a zero pair. And so those equal 0. So 24 does equal 24. So that one's true. And let's see. Let's look at E. That's another one that's a little bit interesting because it has the absolute value. So when you're doing absolute value, you do the subtraction inside of the absolute value first. So 2 minus 7. So you have the negative of the absolute value of 2 minus 7, which is -5, plus 5 equals 0. So this absolute value, so you have negative, the absolute value of 5, right there, is 5. So then you have -5 plus 5 equals 0. So is that true? Well, -5 and 5 are, once again, a zero pair. So that is also true. I'll let you do the rest of them. All right. So we have just a couple more. Which situation could the numeric expression -8 plus 10 represent? Select all that apply. An atom has a positive charge because it contains 8 electrons that each have a charge of -1 and 10 protons that each have a charge of 1. So that could be true because your 8 electrons that have a charge of -1 is going to be your -8. Your 10 protons is going to be your 10. So this one, that one works. Janice sold 8 goldfish for a total of $10. Therefore, she made a profit of $2. That one does not work because you're mixing goldfish and dollars, and so these don't represent this, these numbers don't represent the same things. So that one does not work. See you later, Janice and your goldfish. At a bus stop, 8 people got off the bus and 10 people got on. This means that the number of passengers increased by 2. That works because you're working with people. 8 people getting off could be your -8, and 10 people getting on could be your +8. So that means the number of passengers increased by 2. That could work.
Here's what I found.
The temperature dropped 8 degrees and then another 10 degrees. The temperature is now -18 degrees. Well, that one doesn't work because you're adding another negative, so you're actually going to go more negative. This is a true statement, but it doesn't represent this. So D is, see you later. Who wants to be in negative 18 degrees anyways? Okay, in golf, each hole has a score called par, which is the number of strokes a good golfer should take to get the ball in the hole. Scores that are under par are represented by a negative number. The table shows the golf course for team members in the golf scores for team members in a golf tournament. If the team's total is negative 32, what is Curran's score? Oh, so this is interesting. So we have negative 9, negative 15, but we don't know what Curran scored. So I'm going to bring the calculator up here, and we are going to look at this. And so we have negative 9 plus negative 15 plus some number equals negative 32. All right, so one way that we could look at this would be to say negative, let's see, 32 negative, right, plus 9 plus 15 equals negative 8. Okay, let's check that. So we go 9 negative plus 15 negative plus 8 negative equals 32. So that's the correct answer. I really like that question because it makes us think algebraically where we have a missing value here, but we already know what the result is. And so so if we wanted to model that, then we could draw a number line and say, okay, we're already at negative 9, and then we go another negative 15 to get us to negative 24, and then but we're trying to get to negative 32, and so we could count these as being going down 8 more to get to negative 32. That's one way that we could model it. Another way could be where we have this score of negative 32, and we have a score of negative 9 and a score of negative 15. And we need to know what this little bit is here. And through the arithmetic that we did, we found out it was negative 32. Okay, our last question for today. Austin is watching a football game. His team loses 9 yards and then gains 5 yards. He doesn't watch the next play, but afterwards he sees his team now has a total loss of 1 yard. How many yards did the team gain or lose on the play Austin missed? All right, so if we're here, we've got 0, and he loses 9 yards. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So these numbers are small enough that it's easier to write them all on a number line. But we're going to start our expression to say negative 9 because he loses 9 yards. Then he gains 5, so that's 1, 2, 3, 4, 5, and negative 8, negative 7, negative 6, negative 5. So that's negative 4. So negative 9 plus 5 equals negative 4. And now he sees that they're at negative 1 yard right here after he misses the play. So this right here, this part right here, that is the amount of yards that they gained in between the play. And so that is the difference between, the way we can set that up is negative 1 minus negative 4. The difference, so that's why that's subtraction. between -1 and -4. So if we're modeling it, we can look at it and say, oh, well, that's pretty easy. It's 1, 2, 3. So 3 yards is how much they gained. So they gained 3 yards. But if we're setting up the difference between -4 and -1, then what we want to do is turn this to an addition problem. And so that is -1 plus 4, which equals 3. So once again, 3-yard gain is the result. This is called a two-step problem. Both of these 5 and 6 are two-step problems because we needed to do one step here before we could do the next step, especially on number 6, where we had to find that we had gotten to -4 so that we could find the difference between -1 and -4. And that is our work today.